Hi, good student. My name is Samson Emeka, aka Igwe. If today is your first day of coming across this channel, you can hit the subscription button and also the bell beside it for more videos. Today we'll be talking about rate law, order of reaction, and molecularity of reaction. When we are talking about rate law, it's just like a law that is governing the rate of reaction. Rate law is an experimentally determined relationship between the rate of reaction and the concentration of the reactant. It is experimentally determined. It's not a theoretical concept. So when we are talking about the rate law, we must carry out an experiment to be able to ensure that the answer we get can give us the actual order of the reaction, whether it's going to be first order, second order, fractional order. So in that case, the definition is here. It is an experimentally determined relationship between rate of reaction and concentration of reactant. Of course, we know that rate of reaction is directly proportional to concentration of reactant. Now, if we consider a hypothetical reaction, A, giving us a product, we can express it in terms of rate law. The rate is proportional to the concentration. This stands for concentration, the square bracket, the concentration of A. Then rate of the reaction will now be equals to Ka. We use the K to remove the proportionality sign. Dk stands for constant. It is called the rate constant. If you don't want to call it rate constant, you can call it rate velocity. So it's just a proportionality constant that you use to remove this proportionality sign that you see there. So what we have seen here is called the rate law for this reaction. So whenever you are asked to write the rate law for a reaction, you just say that the rate of the reaction is proportional to the concentration of the reactant. The reactant is what we are considering. So remove the proportionality sign and you introduce a constant. From there you can now get the rate law. This is the rate law. Now, if you are asked to write the rate law for this reaction, we have nitrogen reacting with hydrogen, giving us a product. And you are asked to express the rate law for this reaction. The rate law for this reaction will become rate is equal to K multiplied by the concentration of the reactant. We have two reactants there, nitrogen and hydrogen. So the first reactant is nitrogen, and number of mole here is 1. So nitrogen raised to power 1. Then the next one is hydrogen, and number of mole of hydrogen is 3. So raised to power 3. This becomes the rate law for this reaction. So that's how to write the rate law for a reaction. It's just a relationship between rate of reaction and the concentration of the reactant. If the concentration of the reactant, if the number of mole there is 1, you raise it to power 1. If the number of mole of the reactant is 2 or 3, you raise it to the power of the mole. Again, if you are asked to write the rate law expression for this reaction, SO2 plus oxygen, giving me SO3. Then the rate law for this reaction, now the equation is balanced, because before you write any rate law, ensure that your equation is balanced. The equation is balanced. We have 2 sulfur here, 2 sulfur, oxygen 6, 2 times 3, oxygen 6. So now the rate, you write the rate is equals to K. Then the concentration of the first reactant, you open a square bracket. The square bracket means concentration. Then raised to the power of the mole. The mole here is 2. Then the next reactant is oxygen. The number of mole there is 1. So this is the rate law for this reaction. That is how to write rate law for a reaction. Because without the rate law, you can't get the order of a reaction. The rate law is important because it's a relationship between the rate of the reaction and concentration of the reactant. The next is order of reaction. Order of reaction simply means the sum of the power of the concentration term in the rate law. The sum of the power of the concentration term in the rate law. Order of reaction, sum of power of concentration term. In rate law. So when you add the power of the concentration terms in the rate law, you will get the order of the reaction, and that is called the overall order of the reaction. So here we are referring to the overall order. That's why we say sum of the power of the concentration terms. So like in this equation, if you are asked to state the order of this reaction, the order of this reaction will now be equal to the reactant concentration here now, the power here is 2. Then the next one now, the power is 1. So sum of the powers here now is 3. So this is a third order reaction. The order of the reaction here is a third order reaction. If you look at this one now and you want to know the order of this reaction, you add the powers. The power here is nitrogen is 1, then hydrogen is 3. The order of the reaction becomes order equals to 1 plus 3, which is 4. So it is a fourth order reaction, while this one is a third order reaction. If I have hydrogen plus iodine, and I'm having a product, hydrogen iodide, and the question says you should find the order of this reaction. With the equation here, we can get the order, but the actual way to get order is from my experiment. But this is an equation relating hydrogen and iodine. From this equation, if I'm asked to determine the order of the reaction, what I will now say is that rate of reaction is equals to K. Then the concentration of hydrogen, number of mole here is 1. So concentration of iodine, number of mole is 1. So the order of the reaction is the sum. Order of the reaction is sum of power of the concentration term. The power here is 1. Then the other power is also 1. Sum of the power will give me 2. So the reaction becomes second order reaction. So this is the way to get the order of a reaction from the rate law. You must know the rate law of the reaction. Then the powers of the concentration there, you sum them up, you now get the overall order of the reaction. But if the question says I should find the order of the reaction with respect to hydrogen, the order of the reaction with respect to hydrogen here is 1. The order of the reaction with respect to iodine is 1. But the overall is the sum of all of them. If you come to this place now, the order of the reaction with respect to nitrogen is 1. The order of the reaction with respect to hydrogen is 3. But the overall order is the summation of both of the nitrogen and the hydrogen, which is what we have gotten here as well, 4.